Dun, 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 dun. Oh, hey there, fellow wackadoos. Hello again, and welcome back to Dr. Doodle's QBasic Asylum, where, as always, 'tis I, your guide and chief nut job in these here parts, the one and only Dr. Doodle. That's me. Yeah, so up till now, up to this point, well, I guess this, first of all, this is episode 8, I think. Let's see, 9 minus 1 plus 4. Yeah, episode 8. So, up to this point, my videos, it's getting hot to take this off. My videos are pretty much focused on some pretty fundamental topics. Arrays, variables, constants, keyboard, keys, things like that. But this time, it's going to be kind of a simple one here. Just a little eye candy. Nothing new to speak of, but I think it'll be fun. This one is what I call HyperSpace, and it's, I guess you might call it a screensaver or a cut screen sort of thing. And well, I'll show you. Take a look. You'll see what I mean. All right, so here we have QBA08.base. This is the HyperSpace program I was talking about. Like I say, it's sort of a screensaver sort of thing. Let me run this here. Start, and I won't lie, this was inspired pretty much by the flying windows that you'll see in like in Windows 3.1. Ooh, hyperspace, look at all them stars coming at you. You could use this, like I say, as a screensaver, or maybe even a cut screen sort of thing. As say, for example, you got a, I don't know, you're writing Gallagher or something. You finish one level, and you're moving on to the next. You could have this in between levels while your program loads up the graphics and things like that, sounds, all that stuff. Once it's ready to go, you bring up the next level, and there you go. So, yeah, this is a pretty simple one. We'll show you how this works pretty quick, and here we go. Alright, now the code you're about to see may seem a little bit dense to begin with, but considering who wrote it, that should be no surprise. In any case, before we get into that, I'll just show you the basic process, how it all works, or the concept behind it. Now, imagine this paper here is our computer screen, and for this particular experiment, we'll imagine that the screen is 200 pixels wide by 200 high. Now, screen 13 is actually 320 by 200, but for now, we'll just say it's 200 wide, 200 high. Okay, and so here, right here is the center, the X there. That's 100 pixels to the left of the screen here, and that's our center point. So we have a constant we set up called center X, which will have the 100 right here because that's always going to be the center. What we do to begin the process is we start by, we define our center position, X, right there at 100 pixels, and then we generate a new X position. We call a subroutine that called scatter. What it does, it generates a number, well, let's see, it'll be from 75 to 125. So it'll come up with an X somewhere 25 pixels to the left or to the right of the center here, and that'll be our new start. After that, what it does is it subtracts the new start position from the center, and that gives us our delta. Now, I should point out that you can name your variables and constants anything you like, but typically by convention, X or horizontal positions, most programmers call that X, and most call the vertical position Y, so X and Y, again, just like Cartesian math and everything else. And change is known as delta. So if you change something, that's a delta. So what we do, we take our starting position, our center, and we run the scatter program, which generates the number. Let's say, for example, it comes up with the number 99, and that's our new X position. And then the next time through the loop, it takes the 99, excuse me, and subtracts that from 100. It gives us 1. So that's our new delta is 1, and subtract that's 98. Okay, so now our X is here. You notice it's going to the left. Next time through, our new X is 98. So we subtract that from 100. Our new delta is 2. Okay, so 98 minus 2 is 96. So it's here. Then we go through again, same process. We subtract the 96 from 100. That's 4, a delta of 4, change of 4. Subtract that from 96, puts us in 92, which is about here. So basically, each time it takes the change the new position, subtracts that from the center position. That's our new delta, our change. It then subtracts that from our new position, our old position I should say, gives us the new position, so it moves x, x, and it moves that way. Eventually at some point the x position will run off the side of the screen, at which point we're going to call the scramble subroutine again, and that will generate a new random number somewhere around the center from where to start again. Now let's say we run off the side of the screen, it generates a new number. This time instead of 100, it's 101. And so we take 100, subtract 101, we get -1 for our new delta, our new change. Okay, so we subtract -1 from 101, and we get 102. Wait, what? Subtract 1, you get 102? Well, let me put it this way. I'll show you. Hold on a second. All right, so I hear some of you smarty pants out there thinking, now hold on there, Dr. Doodle. Y'all done lost your damn mind. You're telling me you subtract 1 and the number goes up? How's that going to work? That ain't right. Well, normally it isn't. I mean, look at here. I'm a rich man. I got $5 bill. So here they are, and if I subtract 1, well, now I got 4. That's no good. I subtract another 1 and down to 3. Nah, I don't like that. That's no good. Well, I subtracted it because you know what? Well, my car busted down and the dishwasher busted down, the washing machine. So now I've got, look at here, instead of 1s, I've got, there's the bill for services. Bill for service rendered. Are they all on screen there? There we go, yeah. So now, what have I got here? I've got a 1, I got a 1, I got a -1, -1, and -1. Because that's a bill, see, I got to pay that. All right. Well, if I subtract a 1, +1, I'm down to 1, actually less than 1 because I owe 3, I've only got it out. But what happens if I subtract a -1? Boop, look at here, 2 and -2, it's 0. So I've actually gone up from -1 up to 0. Subtract another -1, look at there. I get rid of these guys, I got 1 now, see? So the more you subtract the negative, you're actually going up. Even though you're subtracting, you're not subtracting the positive, you're subtracting negative. See here? It's a bill for service rendered there. Subtract a negative and your number goes up. That's how you go to the right, because if you start the center point and you subtract a larger number, you end up with a negative number. Here, let's get this back here. Start here in the center, subtract a larger number, you end up with a negative number. You subtract that negative, it's like a bill, getting rid of a bill you've paid, and now the number goes up, moves to the right. Same with the vertical, left and up and down. So that's how that works. Okay, back to the main video, hang on. So in the case, we've subtracted our delta here, and we got 102 here. Next time through the loop, we take 102, subtract that from 100, that's a -2. Now our delta is -2, so we subtract that from here, and we get 104, which is here. Okay, now it's to the right here, the number's going higher, so go through the loop again. Our delta is now 4. We subtract 104 from 100, that's 4, and we subtract a -4 from here, which makes it 108. In any case, it's the same idea. It just moves farther and farther to the right. Again, once it gets to the right, we call the scramble function again to bring it back to the center, start the whole process all over again. As for the Y position, the vertical, same thing. We just do it up and down. We do the same process with Y that we do with X. We generate some random number, we subtract it from the center, that gives us our delta, which tells us where to put the next position. We go through again, subtract the delta from 100, and that gives us a new delta. We subtract that from our position, gives us the next position, around, 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 just like that. Some of you more astute Padawans out there may have noticed a potential problem here. You see, the scramble subroutine generates a number anywhere from 125 pixels to the left, 25 pixels to the right of the center, including the center. Now what if the scramble happens to generate 100? Well, 100 minus 100 is 0, so our delta is 0, our change is 0, then it stays right there, which sounds like it could be a problem. Well, it generally isn't, because if it is 0 here, then it'll just stay somewhere in the center. And normally the X or the Y, excuse me, will be going up or down. Eventually it'll end up off screen. Same with Y. If the Y ends up in the center where it's not changing, then it'll drift off the left, off the right. So essentially the only problem would be if both delta X and delta Y are 0, which, well, how often would that happen? Well, it turns out quite often. So what I've done here is I've created a function to check whether they're both delta X and delta Y are 0, in which case we call scramble and keep calling scramble till we get something we can work with. So let's take a look at the code, and maybe that'll make a little more sense. Here we go. All right, as I mentioned before, this is QBA08.base HyperSpace, and you just slam the link down below there to download this puppy. You can look at it and make it work and see what happens. So as I mentioned earlier, what we do while we well, first off, we start initializing the program here. We set up our we've talked about this one before. Default integer or define integer A through Z, so that all our variables will be integers unless we specify otherwise, and this just makes it run a little quicker. Then screen 13 puts it in screen mode. Again, this is 320 wide by 200 pixels high with 256 colors. Now randomize timer. Randomize, what that does is the RND function, which you'll see down there later, generates a random number. But you can randomize it with a specific number like 10 or 20 or 30, and it generates what's called a pseudo-random sequence. Like if we randomize this with, say, 5, it'll generate a bunch of numbers. The random generates numbers from 0 to 1. And I think I've talked about this with the video 1 or 2 or 3. So it generates a number between 1 and 0, and it's randomized. Now in this case, we're randomizing it with the timer. Reason for this is the timer that counts how many clicks that the computer's done since midnight, and it's always different. You're never going to run the program this exact same time every day, so we've got a different seed, a different number to randomize to. That makes sure that the numbers are always really random. And then option base 1, we really don't need that. Basically what that does is when I see I've got my arrays here, old X, old Y, etc. And normally you'll start counting from 0 to 10, for example, or 0 to 9. Well, the option base 1 starts counting from 1 to 10 instead of 0 to 9. In this case, it really doesn't matter, but I just thought I'd show that you can use it if you want to. So we're setting the default integers. Screen mode is graphics mode 13. We randomize by the timer so that we get a truly random sequence of numbers when we want to set up our new our new stars. Center them in the center there. Then option base 1. Now constants, we got center X is 160 and center Y, because remember it's 320, so 160 is half of that, and 100 is 200 high, so half of that is 100. You don't really need to be constants there, but those numbers are never going to change, so I just thought I'd throw constants in there to show how these might be used. Now the warp speed is 0.5, we'll get to that. Number of stars, well, num stars, it's how many stars you're going to have at any given time. And the option is 0. We'll talk about that later as well. So now we need to set up some arrays. Dim old X, number of stars, old Y, number of stars, new X, number of stars, new Y, number of stars, delta X, number of stars, and delta Y, number of stars, then color, number of stars. What's all this? Well, if we were doing just one star going this way and that way, it would look kind of dumb, just one star at a time. You saw they were all like this. In order to do that, we set up an array with 200 stars in this case. You can change that to 150 watt, 500, whatever. And then this goes through and calculates the X, the old X for every star in the set, the new old Y for every star in the set, the new X for every star, the new Y for every star. Same idea. Now here we get to with the delta X and delta Y, that's the change in position we talked about earlier. And color is the color for every particular star from 0 to 200, or 1 to 100 I should say. Now we start at from 1 to the number of stars. If C is greater than 15, then C equals 0. Now it starts out C is 0 because we haven't set it yet. So C equals C plus 1, and color I, whichever star, the first star in the set, the second star, the third star, whatever, is equal to C. So it starts out, the first star is 1, which is blue. The next one comes around here, we add 1. It'll be 2, which is green. The next star will be 3, which is kind of aqua, excuse me. And then 4 is red, etc., etc., etc. We get up to 15, which is white, and sets the 15th star the color white. Now, if it comes through again, it's over 15, then it sets it back to 0, which is black, but then we add 1 back to blue and start all over again. What that basically does, it just loads this array with numbers for the different colors of the different stars. Once all that's done, we start with our main program, which, by the way, if you notice these, I went to options and I select the display scroll bars. Just, it's easier to scroll up and down with them. I generally don't like them there, but it just makes it easier to scroll. So we'll do this. We'll scroll here. Nope, a little too far. I guess it does make it easier, huh? A little too easier. So here's our main program. Do and loop until len inky. That's another way. Remember before we had do until inky equals is greater than the null. Well, this is just another way, a little cleaner way of doing it. Basically, inky, the length of inky is nothing. Not even 0, it's just nothing until you hit a key. So loops, this do loops until you hit a key, basically. If there's some length there, you've hit a key and it drops down, system ends. So we're looping for I to the number of stars. Basically, imagine there's just one star. We're doing this for next to load each star in the set, in the array. But for this purpose, for all intents and purposes, it does the same thing for each star, so just ignore all the arrays for the moment. Now, first thing we do, line from there to there, 0 box fill. What's that? That's a black square. That sets the black square right in the center to erase. Well, you'll see later on. I'll show you now what happens. We'll just disable that, run, start. Boom, here they come. Now, we've got all these stars zipping off the side, and as they do, notice that little star right there in the center that's stuck. That's every time. Yeah, there's another one. As the scramble subroutine generates a new function, or a new value for these stars, they're right in the center there. They get kind of stuck. So what I do is what we do, what the program does, I guess I should say, let's call this 10 so you'll see what I'm talking about. Start. It puts that little, normally it's a black box, but I've just made it green so you can see it. It puts that green box there, normally black, to erase all those dots that were stuck in the center. That's all that function does. Alrighty, make that back to 0. Now this next line, old x, old y, new x, new y, 0. What that does is, well, I'll disable that, and you'll notice. See what's happening here is it's not erasing the old positions, because that line is what erases the old positions. What this does is put that back there. It draws a line from the old x, the old x and old y to new x and new y, and it makes that black, which is 0. That effectively erases the old position. Then you draw the new one, erase the old one, draw the new one, erase the old one, draw the new one, etc., etc., etc. So all that does is it gets rid of the old information, the old imagery on the screen. Now, if new x, so for whichever, the first star in the set, the second, the third, for whichever one, if the new x is less than 30, or the new x is greater than 371. What that means, if it's gone off the screen this way, or if it's gone off the screen that way. Or if it's gone off, that's less than 30y, or the new y is greater than 220. If it's gone off, basically if it's gone off the screen either way, then we go sub scramble. And I'll show you scramble here for the moment. Scramble is what I mentioned earlier that generates the random numbers. So scroll up here. Oh, I guess that's as far as we go. So scramble here, we got new x equals random. So there's the random function I was talking about, times 50. And random, again, generates a pseudo-random number, which between 0 and 1, which is 0.5, 0.7, 0.9, that's not going to help us. But if we multiply by 50, well, what's 0.5 times 50? That's 25. And so basically, this comes up with a number somewhere between 0 to 50, or I'm sorry, 0.0001 to 0.9999, from 0 to 1, somewhere in there, times 50, and then that gives the random of 25 minus 25 plus. But so let me just explain this a little better here. Okay, so here's our center, like we spoke before. Now we got 50 pixels. If we just do 0 to 50, it'll be over here on the left-hand side. So we want to add the center. But if we just add the center, then it'll be from the center over right, over this side. We want it centered this way. So we have to take the 50 pixels, we add the center, and then subtract 25 to center it around the center, if that makes any sense. Because center is 100, we'd have 101, 102, 103, 104, etc. But we want to be below 100 or above 100. So we take our 50 pixels wide, a range, if you will, of 50 pixels. We add to the center, which puts it here, and then we subtract 25, so it's toward the center. Now it can generate this one, that one, that one, this one, anywhere in this range. And again, the same with the vertical. So here we go. So if it's off the screen this way, off screen that way, this way, that way, any which way, or even diagonal, whichever, then it will go sub to scramble, which this generates a new random X position and a new random Y position. So it's random times 50 plus the center minus 25. Same with Y, random times 50 plus the center minus 25. Now the delta X, that's the change in X. It takes the center, subtracts the new X position, which we just calculated. That gives us our delta X. Same with delta Y. It takes the center Y, subtracts the new Y, and that's our new delta. So we've scrambled our pixels, got a new starting position, and if opt equals 1, we'll look at that in a minute. But first of all, we save our old X with new X. Old X equals new X, old Y equals new Y. We save those old X and Y for later. Now we calculate new X. New X equals new X minus delta X. So whatever it is now, minus the change in delta, and we multiply by warp, which if you saw earlier was 0.5. That's just like a speed function or speed factor. I like 0.5. 1 is a little too fast, to my opinion, but you can change it however you like. Same with Y. The new Y is the same as, it takes wherever the new Y is now and subtracts delta Y. Now remember, if we subtract, of course, if it's a positive, we're subtracting, it goes to the left, or minus, excuse me. If we subtract a negative, then it goes down. And multiply by warp, that's our new X position, our new Y position. Now we draw a line from the old X and the old Y, which we saved right here, to the new X and the new Y, and whatever color is in the array for star number 1, star number 2, star number 3. So then I goes back up and repeat the process for the next star. Back to 1 to I, repeat the process for the next star, all 200 stars. Once we plotted all our new positions, drawn all our new positions, then we loop back to the beginning. We draw the line in the center to get rid of those stars that are stuck in the center. The line here to get rid of the old positions, wipe out the screen basically. And then we check if any of the stars have gone off screen. If so, we go sub scramble if they're here. Maybe this one here has gone off screen. We reset it, but keep the other ones going. I get the feeling I'm not explaining this too well, but like I say, just go through it line by line. You'll understand what's happening there. Now, if option equals 1, then delta equals X minus center else. Let me explain this here. Well, first of all, I'll show you what it looks like. Right now the option is 0, and if we do 1, run, start, pew, it goes a little faster. And I will slow it down for a moment here. Control function, was it 11, I think? Slow down, you. There we go, yeah. Oh, that's too slow. Okay, so let's see if we can follow one. This will be tough. But if you look at any one of these these stars coming at you, if you notice, with option 1, what it does each time it, like I say, through the loop, it compares and creates a new delta, meaning it's going faster and faster. See how long these are here, where in the center they're short, and then they're short, and they get longer as they come out. That's because, like I mentioned before, it gets farther and farther and faster from the center. Whereas when option is set to 0, then what happens is it calculates the delta the first time, and it keeps that same delta. That's why, for example, you'll see like these little short guys, they're not getting any longer, they're not moving any faster, because when it first sets the new position, it calculates the delta and it keeps it like that. Sometimes if it starts towards the center, it's very slow. See the little pixels going very slowly, where if it starts farther from the center, the delta is larger, so it moves out at a faster pace. I personally like this look a little different because it makes it, to me, it seems more depth. Some are faster, some are shorter. But if you prefer, you can put the option back to 1, and then it will actually do as I explained before. It recalculates the delta each time through the loop, but that's just too fast for my liking. Actually, we'll do this here. 0, and then speed DOS box back up to where it was. Run this again. Doop, there we go. Look at that. So, as I mentioned before, it's a pretty simple concept. Basically, oh, and warp. I should talk about warp. Here's okay, the number star. Look at warp. We'll make this say 0.25, and we'll see what happens. See how much slower it goes, and the stars are much smaller. Now if I put this up to 1, there, run, start, pew, again, basically like it was before, very fast, and you'll still have the shorter ones in the background there. I think that's a little too fast. That's why I like 0.5, which slows it down a hair. It just multiplies, or actually divides by 2, because it multiplies by 0.5, which is the same thing as dividing by 2. Run, start, and boom, just like we started. Almost like a supernova, boom, a planet exploding or something, who knows. So we'll go through this one more time quick, and hopefully, like I say, if any questions, just let me know. I know I didn't explain this entirely well, but we start by initializing the program. We set all our variables to integer by default. Screen mode 13 for graphics. We'll randomize the random function generator seated with the timer. Option base 1, which in fact we can just set this to 0 in fact, and you'll notice no change really. Because it's not like we care which stars, is that the first star or is that the second star? It doesn't matter which is which. They're all just random to us. And then with our constants, our center X, which is 160, half the screen. Center Y is 100, half the screen. Warp 0.5, in other words, multiply by 0.5 or divide by 2. It slows it down a bit. The number of stars, I like 200. You could do 500. You can do 10, whichever you like. Option is 0. That's, you saw how it had the slower stars in the background. Now our arrays, we got old X and old Y. That's so we can draw the line from here to there, here to there. The new X and new Y, and then delta X, delta Y, that's the change in delta, how far it moves each time between the loops. Color, and that's the color of the particular star. Here we load the color array with the values 1 through 15, 1 through 15, 1 through 15, etc. Next we go to the main program and do loop. We just keep doing this, looping until we hit a key, loop until len in key, and then system ends the program. So for each of the stars in the star array, we'd start with line, that's the 0, the box fill. That's that black box in the center, which erases all the stars that you see if it's not there. Line old X, old Y to new X, new Y, that's 0. The black line, yep, right there, 0. That erases the old positions. Basically restarts the screen, if you will. The new X, if the new X is less than 30, and by the way, it can't be less than 0, because if it hits 0, then you reset it, then this will stay here. You want to make sure that it's all the way off screen. The front and the back is off screen, same top to bottom. So if it's less than 30, then it's off screen. Where's the Y? If the Y is less than 30, minus 30, then it's fully off screen. Then you regenerate, rescramble it. So if new X or new Y is too far this way, too far that way, or if new X, new Y is too far this way, that way, then we go sub-scramble, boop, scramble, which we look down here, and it calculates the new X, random times 50, plus center minus 25. So remember, 50 pixels, give or take, plus the center, minus 25 to center it around the center position. Same with vertical, 50 plus the center, minus 25. So we get some random certain position somewhere in the center of the screen here. Now, that's our new X. To calculate our delta X, or change in X, we take the center, subtract the new position, and if it turns out it's less, we get a positive number, we subtract the positive number, it goes to the left, to the left, to the left. If it's to the right, then we end up with a negative number. And if we subtract the negative, we're adding 1. Remember, we had the bills earlier. If you subtract the negative, it's like getting rid of a bill. So it's adding, adding, adding. Same with vertical. Now we go back to option. If the option is 1, then it recalculates the delta, makes it bigger each time it goes farther from the center. That's why it seems to speed up. Otherwise, it just takes that first delta and keeps that as it goes. It doesn't change from point A to point B. Now the old X equals new Y, old Y equals new, old X equals new X, old Y equals new Y. That just saves the old positions so we know for when we draw our lines later. Here's where we calculate the new X. It's wherever it is now minus the delta times the warp. Remember 0.5 or 0.1, whatever you want to put in there. I like 0.5. New Y equals whatever it is now minus the delta Y times the warp. And then the line old X, old Y from this last point to the new X, new Y, last point to the new point, whatever color this array happens to be. If it's no star number 1, then you what am I saying? If it's star number 1, then maybe it's blue. The number 2 will be 2, which is green. Number 3 is 3, which is a aqua color, and then it just goes through. For next, it loads or draws each of the stars in the set, in the array of stars, number of stars. Then it goes back loose back up here and gets rid of it all over again, over and over and over and over and over. I hope that has explained it. You can look through and change whatever you think you want to. You tinker with it, see what happens. So yeah, there you go. And again, if you have any questions, you think that I'm don't know what I'm talking about, which I can't blame you. But if you got questions, just leave them down that way there, and say, hey dummy, what are you doing to me here? Explain. I don't understand because I'm stupid. Or I'm stupid, not you. Not, you know what I mean. So that's what we got. All right. Wait. Can't leave now. We got the Supeeriors coming up. Hang on. Supeeriors. Okay, gang. So now this episode's Supeeriors section will be highlighting school freeware on YouTube, and I'll show you the screenshot in a moment here. Now school freeware. This is it's a great site too. They've got a whole series of 64 QBasic tutorials. Which now I gotta point one thing out. The tutorials were originally written in QBasic, but it seems now they've redone them in a program called QB64, which is not QBasic. It's a third-party program that is supposed to be basically it's a version of QBasic written by a third company, another company, not Microsoft, that is compatible with 64-bit computers. So it's they just say it's like an updated version of QBasic, put it that way, but it's not by Microsoft. In any case, it's all the tutorials are in QB64, but virtually everything in there should function in QBasic as well. One or two minor tweaks, minor changes maybe. But other than that, they got some great stuff. And as I say, there's 64 different tutorials. But take a look here. All right, so School Freeware here. That's the YouTube channel, School Freeware. Yeah, like the little apple for teacher. Get it? It's cool. Free. All right. So anyway, this is it. And look at here. Now we go. Oop, zoom back out here. Yeah, let's take a look. Ba-da-ba-da. Scroll all the way down here. Boop. There's our QBasic tutorial series. Again, QB64, but it should be compatible with QBasic. 64 different tutorials. But look at here. They've got more than that. They've got speech recognition, tutorials for Word, software with tutorials, assistive tutorials and freeware, Windows speech recognition, Visual Basic, there you go, C++, Visual C++, Excel, SQL, Free Pascal, all kinds of different. I mean, look at this, Windows 8, Science for the home, a lot of, I mean, just hundreds and hundreds of great videos. You can, not just QBasic, but Polar Vortex versus video series. Yeah, you can spend days on this particular channel here. Some great stuff, and again, it's not strictly QBasic, but it should be compatible with QBasic. It's all very well explained, better than anything I can explain. Very well explained, and great graphics and some excellent examples, things which I believe you can download their code as well, and if not, then just type what you see on screen. So I definitely check out School Freeware. I got to tell you, in fact, I don't know why I didn't subscribe on this machine, but there we are, subscribed now. And yeah, ring that bell if you want to. But in any case, School Freeware. There you go, your Supeeriors. And I guess that's all that I got for today. So yeah. So yeah. All right, so that's all I've got for now, which quite honestly is probably a lot more than you wanted anyway. But I want to thank you for sticking around, for joining me in this video disaster fee here. You know, if you want to punish yourself again, I'll be here next time. I don't know when I'll post next, but just keep on coming back and come back in, and we'll do something else. I'll see you later, and as always, hasta la pizza, baby.